Hi everyone, welcome to my channel JEEcorephysics. Here we will discuss advanced physics problems in a clear and logical way. The aim of this channel is to help you build strong concepts and develop problem solving skills, especially for exams like JEE Mains and JEE Advanced. In each video, we will take one interesting problem, break it down step by step. We try to understand the ideas behind it, but just not the formulae. So stay tuned and don't forget to subscribe and join me on this journey through physics. So here is one of the interesting problem. I have taken it from Prescore, right? So here is a statement of the problem. In a rectangular box, a ball bounces elasticity back and forth along the same trajectory, hitting the left wall and the bottom at points A and B from the bottom corner of the box. The distance of A from the common corner is 3 meter and that of B is 4 meter. What is the time in seconds between successive impacts of the ball? So the acceleration due to gravity is given as 10 meter per second square. So what we can understand from the problem basically is right here. They mentioned that there are two walls which are present like this, right? A ball starts its journey from point A, right? And it goes up to the point B. It comes back to the point A again. It goes and comes back. It is going to repeatedly have this motion along the same trajectory. That too, it is going to have elastically. That's what they mentioned. So from this one, what we can understand? So what are these points where it is starting and ending and henceforth it is repeating or rebouncing? So this point is at a distance of 3 meter they have mentioned from this corner, and this point is at a distance of 4 meter they have mentioned from this corner. So from this idea, we have to calculate how much time does it take between successive impacts of the ball. So here goes the solution. So what the first thing we can understand from the given problem here it is, right? So let us assume that we have projected a body with a velocity v1, or a body starts with a velocity v1 bar. So from the point A, and it's going to hit the surface, the other surface basically with a velocity v2 bar at the point B. Here we can understand that this motion is going to repeatedly happening here. So first of all, we can conclude that the velocity vectors basically will be making like an angle 90 degrees with the respective surfaces. So therefore, they can bounce back elastically and repeat in the same direction the motion basically, and it's going to be opposite. We are going to say it as. So that's how basically we can understand from the basic statement of the problem. Now, how we can go the solution, how to get that answer and all, we'll see. Here, we are going to use only two basic fundamental concepts, whatever we know, right? If any body is accelerating that too uniformly, we can calculate by equations of motion what is the velocity of the body after any time t. And the second one here, right, how to calculate average velocity in a uniformly accelerated motion. So we'll use these two concepts in order to solve this problem. So let us go ahead and we'll see how to solve it. Okay. They mentioned that the body is moving in a uniform gravitational field and acceleration due to gravity is g is equal to 10 meter per second square. Okay. So already we have understood that these velocity vectors must be perpendicular to these two surfaces. And they mentioned that this is a rectangle, right? Since it is a rectangle, we can say the angle between these two edges will be equal to 90. Okay. Since angle between these two edges will be 90, so we can also say, right, V1 bar and V2 bar velocities should be perpendicular to each other. It should be perpendicular to each other. Right, okay. So we can understand that here like angle between two lines will be equal to angle between the normals. Like that also we can ensure that V1 bar and V2 bar should be perpendicular to each other. So therefore hence we can guess first of all V1 bar is perpendicular to V2 bar. This is the first thing we can understand from the statement of the problem. And the second one is how to solve this problem, how to get that answer. Right, okay. Here go like we will solve this problem, right? So suppose if you take this diagram again. So they mentioned that here, right, this corner A is at a distance of 3 meter away from here, and this corner B is at a distance of 4 meter away from here. Therefore, hence, if we calculate the displacement of the body when it is traveling from A to B, we can use rectangular triad and we can say the answer is 5 meter. Therefore, we can say if S bar is displacement of the body, so we can write the magnitude of displacement is equal to 5 meter. The magnitude of displacement is 5 meter, we can say. So using all these ideas, we can calculate how to get that answer. Okay. Suppose, for example, let us assume, let us assume t be the time taken. Let us assume t be the time taken from A to B. So from small a to small b. Let us assume that if t is the time taken from A to B, so I can say that here v1 bar is the initial velocity for this situation or only for this interval of motion, and v2 bar will be the final velocity, right? Now from equations of motion we were aware of, right? Okay, v bar is equal to u bar plus a bar t. So therefore we can write v2 bar is equal to v1 bar plus g bar t. Because it is suffering like, or it is having uniform acceleration g bar, we can write v2 bar is equal to v1 bar plus g bar t, where v2 bar is the velocity after a time t, we can say. So therefore from this one we can say v2 bar minus v1 bar is equal to g bar t. So this is the second equation we can say it as. And what is the third equation we are going to say is, since the body is moving under uniform accelerated motion, for the motion from A to B, we can calculate average velocity like this above. Average velocity is equal to total displacement by total time taken. So S bar be the displacement and time taken from A to B is t. So average velocity is equal to S bar by t. But in any uniform accelerated motion, we know that average velocity we can also calculate by using a formula, first velocity plus last velocity by 2, provided this motion must be uniformly accelerated. Now we can use this technique and we'll try to get that answer. So from here we can write v1 bar plus v2 bar is equal to 2s bar by t, right? So these are third equation we can write. Now v2 bar minus v1 bar is g bar t, v1 bar plus v2 bar is 2s bar by t. So what is the displacement magnitude already we calculated is 5 meters. Now from this one, how can go ahead, how we can get that answer, we will see. Okay. So if we go for right magnitudes of equations 2 and 3, we go for magnitudes of equation 2 and 3, magnitude of v2 bar minus v1 bar is equal to magnitude of g bar into t. But already we have assumed that basically like v1 bar and v2 bar must be perpendicular to each other. We have got that information from the problem itself. Therefore, we can say that equation 2 also as magnitude wise root over v1 square plus v2 square is equal to magnitude of g bar is 10. So 10t we can write. So this is the fourth equation we can frame. Similarly, since v1 bar and v2 bar are perpendicular, either magnitude of v1 bar minus v2 bar or v1 bar plus v2 bar, both must be same. It will be root over v1 square plus v2 square, right? So equation 3 can also be written as magnitude wise root over v1 square plus v2 square is equal to 2 into magnitude of displacement by time. So, and what is the magnitude of displacement? Already we have 5. So it is 2 into 5 by t, which is equal to 10 by t we can write. Therefore, root of v1 square plus v2 square is equal to 10 by t we can write. So this is next equation 5th. Now, so since equation 4th and 5th will indicate only root over v1 square plus v2 square, so we can equate them to each. So 10t is equal to 10 by t. Henceforth, we can say t square is equal to 1. Therefore, t is equal to 1 second. So this is how we can solve this problem, right? We can have other methods of this problem also by taking g into components and all we can do. But this is a simplest method we can use where basic equations of motion, like which already we were aware of, and the properties when a body is having uniform accelerated motion. Hope you like this problem. So kindly subscribe to my channel. Thank you.